Ready? Okay, we are going to find the circumcenter of triangle ABC. So we have points 112, 415, and 712. The triangle's right here. The circumcenter is the point that is equidistant from A, B, and C. So we have learned that if I have a perpendicular bisector, every point on the perpendicular bisector is equidistant from 2 points. But now we have 3 points. So we need to find 2 perpendicular bisectors, and at one point where they're the same will be equidistant. And so we can see clearly on this picture here that this point right here, which is the point 412, is 3 away from A, 3 away from B, and 3 away from C. So our circumcenter should be the point 412. But we need to prove it and find it using both construction, using a compass and a straight edge, and then we also need to do it using algebra. So let's use the compass first. So we need to construct a perpendicular bisector of line segment AB. So we take our compass, we make sure that it is more than half of the line segment. We put the pointy part on point A, and we draw our arc as best as we can. Okay, and then we go over to B, and we do the same thing. And that was not very good. And if we draw our line segment through there, we now have our perpendicular bisector, which you can see intersects at the point 412 right there, so that looks good. If we do another one for line segment BC, hopefully we get the same thing as long as my compass doesn't change size. Oops, like that. Let's see here, there we go. One more, put the pointy part on B, more than halfway. Okay, let's draw that again right through those 2 points. And where did those 2 perpendicular bisectors meet at? They meet right there at the point 412. So we see that our circumcenter should be the point 412 using construction. Okay, now, algebraically, in order to write a perpendicular bisector, we have to first have the equation of our line segment, which I have here. So line segment AB, line segment AB is the equation y equals x plus 11 at a slope of 1. The y-intercept would be right here at 11. The midpoint is 5 halves and 27 halves. So the perpendicular bisector, we're going to use the opposite reciprocal slope, okay, which would be -1, and we're going to use our point right here of the midpoint. So we're going to go y minus 27 over 2 equals -1, the opposite reciprocal of x minus 5 halves. Distribute, we're going to want it in slope-intercept form, so we'll keep going. Distribute that -1, you get negative x plus 5 over 2. Now we're going to add the 27 over. We already have common denominators, which makes life easy. We're going to get negative x, and we add that over. We get 27 plus 5, which is 32 over 2. 32 over 2 is just 16. So my equation of my perpendicular bisector of line segment AB is y equals -x plus 16. Do the same thing over here for line segment BC. So we have a slope of -1 here, so now the opposite reciprocal is +1. So we're going to go y minus 27 over 2 equals 1 times x minus 11 halves. Distribute the 1, which just means the parentheses are going to go away. Again, we have common denominators. Add 27. 27 plus -11 should give me 16. And then, so I get x plus 16 over 2, which is just 8. So now, if I set these two equations equal to each other, because I want to know when are they the same, when do they cross, I'm going to use substitution here. I'm going to get negative x plus 16 equals x plus 8. If I add x over to this side, subtract 8 over here, I get 8 equals 2x, divide by 2, and x equals 4, which it should have been. So now all I have to do is just plug 4 into either one of these equations to see what y is. So y is going to be 4 plus 8, y equals 12. So the circumcenter is the point 4, 12. So using construction, we got 4, 12. Using algebra, we got 4, 12. So the point 4, 12 is equidistant from all three of these points. That is called the circumcenter.